Okay, so we're going to have a look at another question from the 2022 HSC Advanced Maths paper. Now this is question 22. So we're told find the global maximum and minimum values for this function where x is between -1 and 7. So the function in question is a cubic x cubed minus 6x squared plus 8. We're told x has to be greater than or equal to -1, less than or equal to 7. So find the global maximum and minimum values. So first we want to do a first derivative. So we want to say y prime is equal to 3x squared minus 12x, and we're going to set this equal to 0. So setting first derivative equal to 0 usually helps us find maximum and minimum values. So we get, if we do some factorization, we get 3x in front of x minus 4 is equal to 0. Either this is equal to 0 or this is equal to 0. If we get 3x equals 0, this means x is equal to 0. This is one value that produces a maximum or minimum. And if we get x minus 4 equals 0, this gives us x minus 4 equals 0. This tells us that x is going to be 4. This gives us another maximum or minimum value. So what we're going to do is, now that we have these two values, we're going to plot them. We're going to find the y coordinates of them as well, plot them, start to draw this cubic, and it will give us a sense of whether these are global maximums or minimums or not in the domain that we have. So let's find the y coordinates first. When x is 0, y is 8. We just get this from plugging these back into the cubic formula. When x is 4, we get 4 cubed, which is 64, minus 6 times 16, which is, so we have 4 cubed, we'll just put this in the calculator, minus 6 times 4 squared plus 8, that is minus 21. So this value is minus 24. There we go. So now we have these 2 points. We draw a grid. This is our y-axis, this is our x-axis. We'll add 1 point at 4, 24. So we'll try and keep this as scaled as possible. This is 4. This is about minus 24. So there's 1 point down here. And then we have another point at 0, 8. That's about here. This is 8. The function in question is a cubic. It has a positive cube term at the beginning, and that means it must look like this. So it has some general shape that goes this way. It goes up to the right and down to the left. It could also sort of be flat in the middle like this. It's one of these. So this tells us immediately that this has to be the minimum and this has to be the maximum. The only way that the curve can fit through them and keep that shape is something like this. So now we're just going to fill in this graph. I'm just going to say this does something like this over here. This does something like this up here. This curves between these in the middle. Now the problem is the tails that we've drawn on this graph are not to scale necessarily, right? This is not to scale. It's just helping us identify if what we've found is the maximum or not. So 0, 8, this point here, 0, 8, is certainly a maximum. It's either a local maximum, it's definitely a local maximum, incidentally, because it's much bigger than all the points around here. And this point here, 4 minus 24, is definitely a local minimum because it's smaller, lower than all the points around here. The question is, in the range 1 to 7, are these the actual biggest values? They might be, they might not be. The way we're going to check this is we're going to check the values of the function at -1 and the values of the function at 7. Now from my graph, which is not to scale by the way, it looks like -1 is going to be here and 7 is going to be about here. But the curvature of this graph could be completely different. So we need to evaluate these endpoints, because if one of these endpoints, if 7, for example, has a y coordinate bigger than a y value bigger than 8, it is actually the global maximum. Right? 0, 8 would then be a local maximum, and x equals 7, y equals whatever that y value was would be the global. So we need to check the endpoints as well. So we're going to check endpoints. So we have x equals -1. This gives us y is -1 cubed minus 6 times -1 squared plus 8. This is -1 minus 6 plus 8. This is 1. So therefore this point here, this is roughly to scale. This could appear down here. This could be about 8. This is not a global maximum or global minimum. So this endpoint is not a problem for us, right? So this is the first endpoint of the function. We need to check the other endpoint, which is x is 7. This gives us y is 7 cubed minus 6 times 7 squared plus 8. This is 7 cubed is 343 minus 6 times 7 squared minus 6 times 7 squared. That is 294 minus 294 plus 8. So 343 plus 8 is 351 minus 294 should give us 57. So I'm just going to put this whole expression into my calculator as one long string to make sure that this is right. 7 cubed minus 6 times 7 squared plus 8 gives me, 57. So this is correct. This value, we can see that our graph is actually drawn wrong. This curve is much, much steeper than we've imagined. This goes like this. And so when x is 7, actually the function has risen much, much more. Its y coordinate, which we can't even fit on the graph here, is 57. So this point is actually the global maximum. Right? So the global max of the function is the endpoint x is 7. The global min of the function is the local min 4 minus 24. So we found that the global max is actually the endpoint, which is the point 7, 57. And then the global min, which is the local min, is actually 4 minus 24. 4 minus 24. And these were the answers that we were after in this question. So now what we're going to do is we're going to have a look through the approximate marking. You can do these questions in a few different ways. So it's not necessarily a strict type of marking here, but if you do the question this way, there'll be particular things the markers are looking at in order to give you marks. So first, they'll want to see something like a derivative. Right? If you're able to identify that differentiating a function, first derivative equals 0, gives you a max or min, that'll get you a mark. A second mark, they'll want you to solve the derivative equals 0 to find the x values. So once you've done your derivative, setting that equal to 0, solving, that'll be your second mark. The third mark is a little more vague. The third mark will be finding a series of points. So if you have the maximum and the minimum given by the derivative, as well as one endpoint or some other equivalent combination of working, this will give you the third mark. So say, for example, getting down to here, checking this first endpoint is the third mark, and then checking the fourth endpoint, getting the global minimum and global maximum, that will get you the fourth mark. So this is how we do this question.